Okay, Algebra 2, let's take a look at section 3.2. Now, almost every Algebra 2 book I've seen in the world divides this concept up into two different sections, but your book decided in their infinite wisdom to cram it all into 3.2. That is why, for your sanity here, everybody, I'm breaking this up the way I think it should be into two sections. We're going to do 3.A here, and that's just going to be 4 slides, and eventually then, I'm going to start a new video, and we will work on section 3.2b with something called the elimination method. But today here, 3.2a is just going to be this concept here of substitution. Now you'll notice there's not a whole lot that I've written out right here in terms of vocabulary or concepts or theorems or anything like that. All of chapter 3 is about solving a system of equations. And in 3.1, we were drawing graphs. Okay, here was your XY plane, and we would draw one particular line, and then we would draw a second line, and we would look for the point where the two lines crossed, and that would be the one and only solution, in most cases, to our system of equations. But graphing has some limitations, guys. Number one, it can be messy, especially if you're dealing with an ugly slope like, 5/7, or a y-intercept that's a really big number. I don't want to sit here and graph a y-intercept of positive 23. So graphing can be messy. The second thing is, sometimes the solution to a system of equations might have non-integer coordinates. Like, for example, it might be something like 2/3, comma, then it could be something really weird like -11/7. Now, if that's what the solution ended up being, which it could, you're not going to be able to see that from a graph. You're not going to know if that x value was 2/3 or 3/4 or 3/5, anything like that. You can't tell these non-integer values from a graph. So an analytical method, an algebraic method, is going to be more useful to us. And the first one we're going to talk about right here is called substitution. Now, substitution works on the substitution property of equality that you guys learned last year. It basically says then, guys, that if A is equal to, you don't have to write this down, but it says that if A is equal to B, then you can substitute. You can take out an A and replace it with a B anytime you want. Okay, so I would write in geometry, then A and B can be, and here's the phrase for you, this is lots of fun, freely interchanged. All right. I always talk about in basketball how, you've got 5 players on the floor in basketball, and usually 2 of them are relatively short. Those are called your guards. Then you have 2 players, usually, that are a little bit taller here, and those are going to be your forwards. And then you have 1 player who's usually taller than everybody else on the team, and that's your center. And that's the way your basketball lineup usually works. Now, if your center gets in foul trouble or starts to get tired, the coach might say, you know what, Shaquille O'Neal here needs a little break. So we're going to take the center out. And you replace that center with who? Another really small player here? Well, no, that doesn't look like what we had before. You're going to replace your center with another player on your team who hopefully is about the same size. You're going to take out one player and replace them with, or substitute for them, another player who's about the same, if A is equal to B. So that's the key right there. All right, so enough of that, Mr. Fontana. Let's get into our first example. Once again, just like in 3.1, we have 2 linear equations given to us. But I started you guys out with kind of an easy one. In the first equation, the y is already isolated. What does that mean? All by itself on one side of the equation. So we're going to circle that equation right there that has y isolated. And what's important now is that we know, let's just read this very literally, y is equal to 3x minus 11. That's your A equals B right there, guys. You've established an equation, and y on the left side and 3x minus 11 on the right side are equal to each other. They have the exact same value. So what does that mean? Those two quantities there can be freely interchanged. You can take one out and put the other one in anytime you want and anytime it benefits you. So that came from the first equation. We're now going to go to the second equation and rewrite this. Except now that we know the value of y in terms of x, we're going to replace this y right here. So watch what we're going to write here. 7x minus 2. And instead of a y, I'm going to put a blank set of parentheses, and I'm going to finish that sentence now, is equal to 21. And what are we doing now, guys? We're going to take out the y and replace it with what y is equal to, which is 3x minus 11. Okay, so I took out one 7-foot center and replaced it with another 7-foot center. I took out y and replaced it with 3x minus 1. And why can I do that? Because y and 3x minus 11 are equal to each other. The benefit to doing that, guys, is that now, right here, take a look, we now changed a 2-variable equation into a 1-variable equation. Now, it's 7x minus 2 times the quantity 3x minus 11 equals 21. This is a 1-variable equation that you learned how to solve 2 years ago in Algebra 1. How do we do it? We're going to take that negative 2 and distribute it inside the parentheses. So we now get 7x. Negative 2 times 3x is minus 6x. The negative 2 times the negative 11 is going to be plus 22. All of that equals 21. And in Algebra 1, your teacher probably made you do this in 2 separate steps. But we're going to take the training wheels off the bike here, everybody. This is Algebra 2. I think you guys can do 2 things at once. One of the things we have to accomplish now is to combine our like terms, CLT, right there on the 7x minus 6x. At the same time, that 22 that's being added on the left needs to be moved to the right. So at the same time, I'm going to subtract 22 from both sides. Okay, those terms cancel. 7x minus 6x is just plain 1x. We don't need to write the 1 there. Equals 21 minus 22 is negative 1. And right there, guys, that is part of our solution. X is equal to negative 1. Now remember, just like in 3.1, the solution to a system of equations is an ordered pair. An x value, comma, and then a y value. Well, we just found the x value. And now what we're going to do, this is something I need you guys to get in the habit of doing now, we take this value for x and we plug it back in here to the circled equation that had an isolated variable. This isn't the only way to do it, guys, but it's definitely the fastest way to do it. We're basically going to use the substitution property again. Now we're going to take out this x and replace it with negative 1. So y is equal to 3. Instead of an x, we now know that x is equal to negative 1. So we'll substitute that into the equation and a minus 11 at the end. And what do we get here, guys? 3 times negative 1 is negative 3, and negative 3 minus 11 is negative 14. So now we know the y value going along with this x value. So let's put it all together here, guys. Our solution, we did blue already. Let's do a nice, do a dark green right there. So our solution then is the ordered pair. My x coordinate is negative 1. My y coordinate is negative 14. That should be the one and only ordered pair that satisfies not just one, but both of the equations in this system. And let's check that real quick before we go any further here, guys. First equation, y is equal to 3x minus 11. My y value is negative 14. That equals, and let's see if we can do this in our heads, x is negative 1. So 3 times negative 1 is negative 3. Negative 3 minus 11 is negative 14. Negative 14 equals negative 14. Check. That one worked. The second one's going to be a little bit tougher because it's in standard form, but let's see what we can do. 7 times x. 7 times negative 1, I'll cram this down here, is negative 7. Then we've got negative 2 times negative 14. That's a plus 28, and that should equal 21. Well, negative 7 plus 28, sure enough, is 21. Does 21 equal 21? Check. That one works as well. So now that I've checked this solution, what I thought was my solution, in both equations here, and it works, I know for certain that this is the solution to that system of equations, because it's an ordered pair that works not just in one of them, but in both of them. And that, everybody, is how you use the substitution method. Now, that was an easy one because the y was already isolated in the first equation, but it will get harder. Not really yet. Let's take a look at example B. So again, now it's the top equation that's in standard form, and the second one isn't in slope-intercept form. It's solved for x instead of y. Does that bother us? Not really. Slope-intercept form would be important if we were graphing, but we're not graphing these equations. We're just looking for an isolated variable. Do we have that here? Yeah, we do. This time, the second example, or the second equation, excuse me, has isolated the x rather than the y. So we're now going to go back up to the first equation, and we're going to replace this x with what x is equal to right here, negative 4y minus 12. So I'm going to rewrite this first equation, but with the substitution. 3, and in the place of the x, where there'd be an empty set of parentheses, we replace it with what x equals, according to this line, which is negative 4y minus 12. Back to green now, let's finish up that first equation. Plus 6y is equal to 3. And just like the last problem here, guys, we're going to distribute this 3 here to get rid of the parentheses. So that'll be a negative 12y. Looks like a minus 36 plus 6y is equal to 3. Once again, we're going to combine like terms and at the same time move the constant from the left over to the right. So we're going to add 36 on both sides here. Okay, those cancel out. Negative 12y plus 6y is negative 6y equals, and 3 plus 36 is 39. Not cool, Mr. Fontana, because I just gave you, for the first time now, a problem that's going to have a non-integer solution. When you go to divide both sides by negative 6, 39 doesn't divide evenly by that negative 6. So I would imagine most of you guys would go to your calculator right here and just type in 39 divided by negative 6, which I think I could probably do. Whoa, that was weird. All right, hang on a second here, guys. We will use this. We'll just use this guy right here, the Desmos calculator. So what did I have? 39 divided by, no, 36. Let's try that again. Divided by, and this was a negative 9, I believe. Okay, I'm struggling here, guys. It was 39. Jeez, Montana, 39 divided by negative 6. That's what I was looking for. Negative 6.5 is the answer. And since that's a clean decimal, not some weird repeating thing, I'm going to go ahead and just leave that the way it is. That's the way I would imagine most of you guys would handle a decimal answer. If it came out to be something really, really ugly, like a repeating decimal, I'd want to make it a fraction. Remind me in class, I'll show you how to do that. But there you go, guys. That's your y value right there. Now, we're only half done. We have to find the x value that goes along with it. And the best place to do that is to take this y value and put it right back here into the equation where you already had an isolated variable. So let's go to a lovely shade of orange now, everybody, and let's see what happens in this equation when we take out the y and substitute in negative 6.5. X is equal to negative 4 times a y value of negative 6.5 minus 12. So we're going to multiply that first, and we're going to get x equals, all right, a negative 4 times negative 6.5. So I already had the negative 6.5 in there, times, and we had a negative 4 there. Oh, that doesn't work on this calculator, sorry. So negative 6.5 times a negative 4. Oh, man, not my day. All right, get rid of that. There you go, is equal to a positive 26. All right, so we end up with 26 minus 12, and then x is going to equal positive 14. So we now know what x is. We now know what y is. So let's go nice and bold in black here, everybody. In fact, we'll make the pen fatter. Let's put it all together. Our solution is the ordered pair x comma y. X is 14. And then our y value here is negative 6.5. Good, I made that bold enough you could see it from space. And that would be your answer there. And again, if you really wanted to check this, you plug all of that in. what would you get there? A 42 minus, yeah, that first one works. That second one does as well. So once in a while, guys, you will end up with ugly solutions like this one right over here. Okay, so A and B there kind of give you a sense for how most of these problems work. But if I remember right, I think I threw you a little bit of a curveball here on example C. Let's take a look at this one. Now, what makes C harder than A and B, in both of the first two problems, you were given an isolated variable. Here, no such luck. There's four options here then, guys. The first x, the first y, the second x, or the second y. You could choose any of those four variables to isolate, and if you did it very carefully, and if you did it right, I guarantee you, you're going to get the right answer here from any of those four possible moves here. However, some of them are much more work than others. So I want to teach you guys how to make a good decision here. Now, let me just stop right here. What you really want to work on here, guys, is trying to find the smallest coefficient out of the four terms that I just underlined. So our coefficients here are 7, 4, 2, and negative 8. 2 is the smallest out of all those numbers. That means that this variable here with the 2 in front of it is the one that we are going to isolate. So if I want to get the second x by itself, the first thing I'm going to do is add an 8y on both sides here. So 2x, those will cancel, is equal to, and I think most of you would probably prefer to write that as 8y minus 42. Now, we're going to divide by 2 in all three of those terms. And we're going to get an isolated variable, which is what we wanted here. X is equal to 8 divided by 2 is 4y minus 42 divided by 2 is 21. Hey, so it took a little bit of work, but we just isolated a variable. We circle that equation. And now that you've isolated an x, which came from the second equation right here, you're now going to take this x and put it back into the first equation right over here. We're going to get rid of this x and replace it with 4y minus 21 using the substitution property of equality. So this is going to be 7 times an empty set of parentheses plus 4y is equal to 13. And what goes in the parentheses in the place of the x? 4y minus 21. All right, let's distribute that 7 and see where that gets us. 7 times 4y is 28y minus, oh boy, that is 147, fun, plus 4y is equal to 13. I would imagine you guys would be using your calculator here. All right then, everybody, same things as before. We're going to combine like terms here and also add 147 to both sides. Okay, so those terms are going to cancel out. 28y plus 4y is going to leave us with 32y equals, and 13 plus 147 is 160. We'll then divide 32, I should say divide both sides by 32, and we'll get the first half of our solution now. Y is equal to 5. Okay, that's half of our answer. We found the y coordinate, now we need the x coordinate, and the best place to take that is back to the circled equation. So let me go with this lovely shade of brown here. Let's go with that. And here we go. X is equal to, we've got 4 times a y value of 5 we just found, minus 21. So x is equal to 4 times 5 is 20. 20 minus 21 is negative 1. There's the second part of your solution. So now, I'll switch back to black, maybe not make that quite as thick as last time. Let's put it all together now. Our x value to our solution is negative 1, and our y value is 5. That should be the solution to this system of equations. These numbers are a little bit more reasonable, so let me check these guys and find out if they work or not. All right, in the first equation, this one right up here, we've got 7 times x. 7 times negative 1 is negative 7. And then plus 4 times 5, 4 times y, and y is 5. So 4 times 5 is 20. That is supposed to equal this number right here, which is 13. So look at that statement in purple, guys. Is it true? Does negative 7 plus 20 equal 13? Check. It does. 13 equals 13. Now, let's try it in equation number 2. 2x is 2 times negative 1, so that's negative 2, minus 8 times y. 8 times 5 is 40, and all of that should equal negative 42. Does that work? Negative 2 minus 40, yeah, is negative 42. So since this ordered pair works in both of the two equations, then we know for a fact with complete confidence that this is the solution to that system of equations. Okay, so C was harder than A or B because we had to isolate a variable here before we went any further, but that's what you have to do on those problems. Isolate a variable, then do your substitution. Last example with you guys for this video right here. Looks pretty similar to the one we just did. We have two equations in standard form. So, decision time. Which of the 4 variables are we going to isolate? So, we look at the 4 coefficients and we go with the one that has the smallest number. Don't worry about negatives here. My coefficients are 3, 5, 6, and 10. 3 is the smallest. So we're going to work to isolate that x right there, which we will do first by adding 5y on both sides. Let me move over to the right here. We're now going to get, I'll tell you what, I'll switch to blue here with this one. We're now going to get 3x, the 5y's cancel, equals, and I see 12 plus 5y. I think we'd rather write that as 5y plus 12. And now to get x by itself, we're going to divide every term by 3. And something happened here that I know you guys don't like. That's okay, it probably won't kill you. The 3's cancel and we get x equals 5. Does not divide evenly by 3. And as I said just a second ago, I think most of you guys are going to run to your calculator and type this in, but as I'm hoping you knew already, 5 divided by 3, if you look over here to the right, is a repeating decimal. Now, I was okay with you guys writing 6.5 because that's a terminating decimal that actually ends, but we never want to round. Guys, you can't do it. It won't give you the right answer, so we leave our answer as a fraction. So look right here again. What's 5 divided by 3? 5/3. Okay, don't make life hard. The y comes at the end now, and then plus 12 divided by 3 is 4. So I'm going to circle that, everybody. Now we have an isolated variable that came from the first equation. So now we plug this back into the second equation right here below it, and let's see where that gets us. I'm going to switch to green for this one. So now that we know what x is, this is going to be negative 6 times something for x, plus 10y is equal to 4. And what goes in the place of that x right there? This, 5/3 y plus 4. It's now a one-variable equation which we can solve. We're going to distribute that negative 6 in here, and something interesting is about to happen. Negative 6 times 5/3. I don't want you guys just to take my word for this, so I'm going to type it in here. Negative 6 is going to get multiplied by, and I'll hit this fraction here, 5/3. And when I hit enter, take a look on the right, you get negative 10. Negative 6 times 5/3 is negative 10. So this is now negative 10y plus, I'm sorry, that's actually a minus now. Negative 6 times 4 is a minus 24 plus 10y equals 4. Okay, what have we been doing here for the 4th time now? We combine like terms and we get rid of that. Actually, you know what? I'm going to stop right there. We combine like terms and you might have just noticed the weird thing that's about to happen. Negative 10y plus 10y cancels out completely. This hasn't happened yet, guys. All of your y's are gone. So let me just write what's left over. My left side is now just negative 24 equals, and my right side is just 4. Now, in every problem we've done so far, at this point, there's been a variable in this equation that we can solve for. But we better talk right now, guys, about what to do when all of the variables drop out. When that happens, you no longer have what's called a conditional statement. You have a statement that is either true or false. So ask yourself, guys, is negative 24 equal to 4? And the answer, which I hope is pretty obvious, is no, it's not. So this is what we call a false statement, because obviously it's not correct. It's not true. Negative 24 does not equal 4. When that happens, everybody, when all your variables drop out and you're left with a false statement, then this right here is another case which we talked about back in section 3.1 of having no solution to a system of equations. All right, so this is the answer here, not false. That's just something you use to get to the answer. But the answer is that there is no solution to this system of equations. So let's kind of review what just happened here, guys. We were given a system of equations at the beginning here. There are an infinite number of solutions to this equation. And there are an infinite number of solutions to this equation as well. But what we were looking for is a solution that worked both in equation 1 and in equation 2 simultaneously. Well, the fact that all of our variables dropped out and left us with a false statement means that there is no ordered pair that works for both of those two equations simultaneously. If we were graphing, everybody, this would have been one of those cases where we got two parallel lines that never intersect. Okay, this is just another way of arriving at that, so our answer here is no solution. Now, guys, that's about everything weird here that we were going to do in the beginning of section 3.2. So I'm going to wrap this video up, and then later we'll come back and we'll talk about 3.2b, where we start solving systems of equations with a different method that actually most people like better than substitution, called elimination. All right, guys, good luck on the 3.2a homework, and let me know when you have some questions.